my mom's selling it. She missing out.
That's what I'm saying.
Oh, hello everybody.
You can replace it though. Replace it.
Hello.
I can't hear this. Hold up.
So, welcome to class. So,
Listen, I'm trying to connect it.
yes.
Yes. This man. You're going to class now?
All right. So, I did post, about the quiz. Our first quiz will be available right here. If you go to quizzes, if I go to quizzes here, our first quiz will be available right after class, at 2:30 p.m. today. You will have until September 16th at noon, which means Thursday at noon to submit it, okay? All right, so I did post a practice quiz for everybody. This quiz has no math in it, okay? I just posted for all of you to see, to have an idea how to submit your work using Brightspace. But when I go to here, submit your your assignment here. When I say to that, so edit, submit your practice quiz here. Only 3 people did it. Only 3 people did submit. You see, only 3 people right here. You see, new submission, only 3, which means like about 20 of you maybe said, okay, we know how to do the quizzes, you know how, etc., etc. Okay, it's okay. If you know how to do it, it's okay. But Thursday noon, everybody had to submit their work by Thursday noon. If you don't submit your work by Thursday noon, you will have a 0, okay? So basically after class, at 2:30, when you go here, what you're gonna see? You're gonna see quiz number 1, you see? You're gonna see quiz number 1 after class, all right? So what's gonna be right here, you click on the quiz number 1, you're gonna start the quiz number 1, right? You click on start the quiz, and you're gonna see the quiz here, PDF file, right? You see this quiz right here? You click on it, okay, I will not click on it right now. If I do, you're gonna see the questions, okay? It's only like, I think 4 or 5 questions, right? You click on it and you're gonna see the questions, right? When you see the questions, you take a loose paper like this, you write your name, you answer to the questions, right? And then you take your device like a cell phone, where you have a lot of free apps. For instance, me, myself, I have, for instance, I have this app right here. I have it like 2 years now. This is called the Scannable app. You see this app right here? This one, the blue one, Scannable app, right? Okay, I have this app. It is free. It's gonna it allows you to scan papers, right? And you have Acrobat, you have, all those free scanning apps. Some people have iPhones and you can scan with your iPhone also, etc., etc. You scan your paper or your papers, you get a PDF file, you save it on your device. If you want to submit with your device, it's okay. If you want to submit with your computer, you save it somehow on your computer, you send it to yourself, for instance, and you save it on your computer. And then you go here. After you've done that, right? After you've done that, what you do? You go to the assignments, right? You go to the assignments. And when you go to the assignment, you see, submit your quiz 1 here. You click on it, And then it's going to allow you to submit. Okay, me, I don't see the same thing you see. You know, I'm an instructor, I'm a teacher, so I don't see exactly the menu you're going to see. But you, if you click on the submit your quiz one, you're going to see upload the file, add a file. You click on add a file, and then you upload your file. Okay. Okay, so when I did the practice quiz, there is nothing math in it. Okay, you see the practice quiz, there was nothing math. You see. It's just for you to see what you do. I just wanted for you start the quiz. You see, click on the PDF file. That is a practice quiz. You see, I just gave you instructions how to do that. Okay. Please pen your paper or take a loose paper, write your name on it and your section. You can write a short story if you want, or something about math you want to share. Exactly, you know, whatever you want. Then you scan the paper, okay, or take a picture and transfer it to a PDF file, save it to your device, right? And now go, after you've done that, you go to assignments. You go to assignments, you click on submit your practice quiz here, and you put your file. You see, 3 of you did that. You see right here, 3 people did that. Everybody else not. This was about a week ago, okay? So, I mean, don't wait until the day of the quiz and say, I don't know how to do that, I don't know how to do that, okay? So you have to practice stuff, okay? All right.
I have a question.
Yes.
Is it possible if I do the work digitally and still like download it as a file and upload it?
Yeah, you can. Yeah, you can do the work digitally. If I'm able to type, you know, it's just to make it easier for people, just to say take a loose paper and write on it, because not everybody have time to type, you know, the X's and the Y's, etc. Right?
Okay.
But if you can do it digitally or write on your, you know, maybe you have a stylus, you can write on your device. That is very good. Okay.
Thank you.
It's just to have a PDF file. All right.
Yeah, I have a
So,
question.
yes, go ahead, William.
So we have to submit the quiz within the 30 minutes, or like, can we like write the questions down and then like?
Yep. No, look, that is a good question. Don't start the quiz until you feel ready. Okay, this is just a quiz. It's very simple. Okay, you have like few questions. So I mean, let me answer to your question. Once you hit start the quiz, you will have 35 minutes before you submit it. Okay. Okay. If you hit start the quiz at noon, and then you submit your file at 5 o'clock, I give you 0. Okay. That's going to be a very quick 0.
All right.
I have ways. If I go to Brightspace, I can see when everybody started. Okay, I can see that. So you have 35 minutes to you know, let's say 35, 40 minutes. Okay, I'm going to be 35, 40 minutes. Okay. All right. Thank you very much. So we're gonna continue on the inequality stuff, right?
Real quick, what's the name of the app that you scan it on with your phone?
Yes, this is just one app I got myself. It was free, so it was a scannable. But you have a lot of apps. This is one app, right? I think you have Acrobat.
I think if someone has an iPhone, I think the easiest way to scan it is using the Notes app.
Yeah, exactly. If you have an iPhone, you just use the Notes app, right, on the iPhone, you know, etc., etc. Nowadays, I think the scanning stuff, you have a lot of ways to scan nowadays, a lot of, right? Okay, so after that, we're going to continue our math thing. So we were doing the inequalities, right? So now, at first, we're going to see how to solve. We're going to just recall ourselves how to solve linear inequalities. Linear inequalities. Last time we wrote all the intervals, right? So of course, you know, it's going to always start with some easy example, like, you know, like solve 3x minus 15 is less than or equal to, right, 9, right? Something like that. We all know here we have to get x by itself, right? Pretty much we do the same step if it was an equation. We do about the same steps, right? So you know that you're gonna add 15, right? Add 15 here. So you get 3x is less than or equal to 24, right? And then you divide by 3. Now, do you remember if we have if we have an inequality, do you remember what happens if we divide by a negative number? Do you remember that?
The sign.
Yes, the sign changed.
Yes, so inequality
From less
changes,
to
right?
greater.
That is correct. When we divide by a negative number, the inequality changes. But if you divide by a positive number, nothing changes, right? Okay, so here we divide by 3, which is a positive number. We don't have to change nothing, right? So divide by 3 is going to be x is less than 8. Now, so it's going to be solve and write your answer as an interval. It's going to always be like 2 questions: solve, write your answer as an interval. So what interval corresponds to that? X less than or equal to 8. What is the interval? The interval will be, somebody tells me?
Would it be infinity sign and then an 8?
Yeah, go ahead. Tell me exactly what you think. Dictate that to me.
I'm not 100% sure, so.
Yeah, so this is x less than or equal to 8, right?
Or no,
You said the infinity sign. Is that infinity? So what I put first?
negative infinity will be with
If-
parentheses
Negative
infinity,
all the way to
8,
8, and then what I put after 8?
closed.
Bracket, right? Thank you. Okay, so because this is the left side of 8, so this is like my number line. I have negative infinity, positive infinity. I have 8 somewhere. Less than or equal to 8 is about that right here. Okay. So now I give you this one. Try to do it, please. All right, everybody, try to solve this one. And write your answer as an interval. All right, so somebody walks me through the steps, please. What you did first?
Subtract 13
Subtract 13, thank you.
on both sides. And then you divide by -5.
Okay, get -4. So when you divide by -5, what's gonna happen?
You're gonna switch the sign because you dividing it by a negative.
Thank you very much. So we divide by -5. So you see, I prefer go to the next line. Where is it? -5x divided by -5. what was less than will become a greater than,
Positive.
right? Thank you.
Mhm.
-4 divided by -5. So we get x is greater than 4/5. Now,
-2/5.
now it's
Isn't it
4
negative?
so we have two negatives. You see, when you subtract 9 minus 13, you get a -4, right?
Oh, okay.
Yeah, instead of a +4. So x greater than 4/5. What is the interval then? Greater than 4/5. My interval start with what?
Parenthesis,
Uh-huh.
-4
Uh-huh.
over 5, and
Yep.
then you have infinity with another parenthesis.
Thank you very much. You see, because x greater than 4/5, this is the right side of 4/5. I have -infinity, +infinity. I have 4/5 somewhere, and this is the right side of 4/5, and this is open, right?
Yep. Mhm.
Okay. So you see, that was, this is a quick review of linear inequalities. Of course, all of us know how to do that. So now, if you say, what about some compound inequalities? Compound inequalities is when we put together 2, 3, 4, 5 inequalities that are linked with or and. For instance, we say x minus 2 less than or equal to 5, or x 1/2 x greater than or equal to 6, or greater than 6, right? You see? When we say or in the set language, right? In the set language, when we say or, it means the union, right? You have to put together the two solutions. Or means the union of the solutions, all right? And means the intersection. Go ahead. How we solve the first one? By doing what? The first one by doing?
Adding 2.
By adding 2. Thank you. So we get x is less than or equal to 7. Or how we solve the second one? What you do?
Multiply by 2.
Multiply by 2. So when we multiply by 2, do we change anything?
The sign.
When we multiply by 2, do we change the sign? The symbol, the inequality?
Oh, wait, no.
We don't, right? When you multiply by 2, we don't change nothing because 2 is positive, but 2 here, 2 times here is cancelled out. We get x is greater than 12, right? So
Yep.
now, how to graph the solution? Or means the union, you see? What you're gonna do basically, we're gonna graph both of them, and the solution will be when you put them together. We're gonna graph both of them. What is the first one here?
7's greater than x. So
The first one here.
parentheses, infinity,
-infinity to
7.
7, and then close, right?
Right. Yeah.
So which is this one right here. That is the first one right here, right? Second one, how are you going to graph the second one? What number you have? 12, right? X is greater than 12. What's going to be?
X to positive infinity.
Exactly. It's going to be
12 to positive infinity.
12 to positive infinity. You see? This corresponds to this one right here. So since this is a union, what is my solution? My solution is the first one union, the second one, right? We put a big U for the union sign. If it was and, we're gonna put intersection. All right. So let's see another one here, and then you're gonna try to do this. Negative 1/4x less than 2. And now it is and. And means intersection. And, right? And 2x greater than or equal to 6. Solve them. You see the inequalities, they are not hard to solve, right, at all. But what you want to see is how to graph the interval, right? Go ahead, solve each one of them, please. Right here, the one on the left side, what we have to do to get x by itself?
6/2.
The
The
one
left
on-
side.
Yeah,
the
I
left
mean
side.
the black one.
Multiply by -4.
We multiply by -4, right? Okay, what's going to happen when we do that?
We'll
What's
change
going to
the
happen when we
sign.
do that? We change the
change the
symbol,
sign.
right? We change the inequality. So when you multiply by -4, you multiply by -4, something going to change. It's going to be x will become greater than -8. Okay? Obviously, the right one, we don't have to do nothing but to divide by 2, divide by 2. So we get x is greater than or equal to 3. But this is an and, right? And means what? And means intersection. And means intersection. So I'm going to take a couple of colors. I'm gonna graph my two intervals, and then the solution will be the common area, right? That's going to be the solution, the common interval. The first one is -8. You see, I put my two numbers, -8 and 3 somewhere. The first one is x is greater than -8. Which side of -8 I'm going to shade? The right side or the left side?
The right side.
Right side. Everybody agree with that? The first interval is x is greater than -8, like this. And this is open here. The second one, x is greater than or equal to 3. Which side of 3 I'm going to shade? The right
right.
side of 3 or the
Right
left side?
side.
Right side, thank you. And that is close here. The intersection means only the common area, only. Okay, what is the common interval here? From what to what?
Greater than 3.
Exactly. Here's a common area, so solution is interval bracket 3, infinity. Okay.
Why?
What is the end? Yes, go ahead.
So here the interaction will be from -8 to 3, right?
Yes. For the intersection from
No,
-8
no,
to
yeah,
3, do you see both colors?
No, no.
You see only one color you see. The intersection is when we see all the colors represented. right? Okay, so now, you see, for instance, now we have another type of compound stuff. For instance, we say 5 is less than or equal to 2x plus 1, and 2x plus 1 is less than or equal to 9. You see, so what is particular about this type of compound, this type of compound inequalities? What is particular about them? We have somebody who is repeating, right? Don't we? We have something that is repeating in both of them, right?
Yeah, the 2x plus 1.
The 2x plus 1. Only this one, only this type of inequalities we can rewrite at once, okay? Only this one you can write like this. You can write 5 less than 2x plus 1 less than 9, okay? Only when it looks like this. We have the same thing repeating, and what do you have in between? You have and, okay? If we had or, we cannot write it this way, okay? Every time you see something written like this, the and is hidden. You have an and behind the scenes, okay? Everybody agree with that? Every time you see something like that, you have the word and that is hidden. This is two inequalities, and between them you have and, you don't have or. All right? Now, how are you going to solve this? Obviously, you see why it is beneficial to write it this way. Look at both inequalities. They follow exactly the same steps to solve, right? If you want to solve the first one, you have to subtract 1 and divide by 2, right? If you want to solve the second one,
would you do the same thing to both sides? So if you subtract
exactly,
one, you have to subtract- okay.
Because they follow exactly the same steps. That is why it is very beneficial if I write them this way, right? Because we do the same thing, -1, -1, -1, right? It's going to be equal to what? It's going to be equal to 4 less than or equal to 2x less than or equal to 8, right? And then what you do next? Divide by?
Divide by 2.
Divide by 2, divide by 2, divide by 2. So we get 2 less than or equal to x less than or equal to 4.
6.
Now, what interval is that?
Closed.
The interval will be, look, all the numbers, this reads all the numbers between 2 and 4, right? What I see here is all the numbers that are greater than 2 and less than 4. So he said it's all number between 2 and
4.
And they close like this. All right. So this is this type of compound inequality. So I'm gonna put a couple of them here for you to try. All right, go ahead. Do these two compound inequalities. Of course, solving them follow like two simple steps, but you have to watch out when you have to divide, okay? You have to watch out when it comes to dividing. All right, so meanwhile, you can write your name for the attendance, please.
Can you scroll up, please?
Yeah, scroll up like this.
Yeah.
Okay.
Thank you.
Everybody, you can write your name for the attendance.
Sir, I want to ask something. Last week I was here, but I didn't do that. To write my name here.
Hold on. I mean, your sound is cracking a little bit. I've had time to hear. So what you say?
I said
Uh-huh.
last week I didn't write my name here, but
Okay,
I was
okay,
here
okay.
for the class.
I got you. Yeah. I got you.
So,
Thank
okay.
I got you. Last week, right? So
Yeah.
I checked your name.
Okay. Okay. Thanks.
Right. So can somebody tell me what interval they got for the first one?
I got -2 and 1.
-2, 1.
Mhm.
Okay, how are they? The brackets or the parentheses?
Brackets?
Bracket what?
It's
Both of them brackets?
I think it's -2 and -1.
-2 and -1. Let's check that. So
No,
That's what I got.
I got another answer. It's
You got some-
-10 over 3 and
Uh-huh.
-5 over 3.
Oh, okay. So I see like a bunch of numbers, but I think the -2, -1 will be the right one. Because first, what you do first, we have to subtract 7, right? Okay. So when you subtract 7, we get -10 is less than or equal to 5x less than -5. And then we divide by what?
5.
By 5, right? So you see where you get -2 less than or equal to x less than -1. Now, when you graph it now, is all the numbers between -2 and -1,
Yes.
right? It is closed at -2, but open at -1, right?
Mhm.
So your interval will be the interval -2 bracket -2, comma 1 parentheses. All right. For the other one, now, of
Yeah.
course, what do you get for the other one? What numbers?
6 and 8.
-6 and -8.
-8
-8.
and -6. No. -8 and -6.
Yeah,
-8,
-6.
-6.
Negative
Okay.
6
So
and -8.
which number comes first?
-6. Wow.
-8.
Okay. So you see,
-6.
I
You have
thought
to pay attention
-6
to
and
the,
-7. -7 would come first.
yeah, but you know, I think the numbers will be -6 and -8. Because look, that avoid mistakes. When you add one,
Add one, add one.
it becomes 12
Negative
less
2,
than -2x less than 16, right?
and divide by
Now, when you
negative 2.
divide by -2, what's going to happen when you divide by -2?
You gotta switch the
You get
signs.
-6 and
Exactly, you
-8.
have to switch the symbols, right? We have to switch the inequalities. When we divide with 2,
So
12
it'll be
divided by -2, this becomes greater than or equal to -2x divided by -2 and greater than 16 divided by -2, right?
Mhm.
Okay, everybody see that? Don't forget to change them. It's going to be -6 greater than x greater than -8.
Negative 8.
When I said the first number is -8, I changed.
Your sound is a little bit breaking. It's very hard to hear what you're saying exactly, Sharif. So maybe there is some interference. Yeah, maybe there is some interference. You know, when you hear now, yeah, it's very hard to hear what you're saying. So you can type it. You can type it on the chat. When you are here now, you can switch here. I mean, you can rewrite this. If this stuff is kind of confusing for some, you can say -8 less than x less than -6, okay? These two ways are exactly the same. Okay, but what is the key here? The key is when we divide by -2, we don't forget to change the inequalities, right? That is the key, okay? When you divide by -2, you don't forget to change the inequality. So you get -8 here, and we get -6 here, and all the numbers between them, right? Okay. So these are reviews of how to solve linear inequalities. Now, I think here we're gonna do something, how to solve absolute value inequalities. And this is, we need to focus here, absolute value inequalities. We don't treat them as something very trivial. We don't. Absolute value inequalities, we have to treat them seriously, okay? So the first example, the very first example here, if it says solve absolute value of x is less than or equal to 2, right? That is a very simple first example. I just want to give you an idea how to approach this stuff, how to approach them. So basically, what are the numbers whose absolute value in between is less than 2, right? What are the numbers? So let's try to get an idea. Let me draw my number line. I have -infinity, infinity, right? Okay, look, I have 2 somewhere. Okay, if any number is here between 0 and 2, if any number is here, do they verify this inequality?
No.
All the numbers between 0 and 2, that you know, in red, all the numbers in red, do they verify absolute value is less than 2? You can pick numbers in your head. Not all of them?
Not all of them.
So, okay, let's pick like 0.5. How much is absolute value of 0.5? Is 0.5, right? Is it less than 2? Is it less than or equal to 2?
No.
It's less than, it could be less than.
Okay. I understand why you guys hesitating. I understand.
Can I say what I think?
Yeah, go ahead.
It will be like less than 2 and between 2 and -2.
Yeah, that's the final, exactly. That's the final, that is the final answer. So that is the final answer, you are right. But I want to walk you over the steps. I understand why you guys hesitating, because last time, look, when you say is 6 less than or equal to 9, is that true or not?
No, it's not.
It's true.
It is
because
true.
it
The
could.
confusion comes from here. 6 is less than or equal to 9. That is true. Because in this statement, it say less than or equal to, right? Whatever part is true, the whole thing is true, okay? If one of the part is true, then the whole statement is true because we have or. 6 is less than 9, right? You see, for 6 less than 9, this part is true. Then the whole thing is true. When you say 9 is less than or equal to 9, is that true or not?
Yes, it is true.
It is true.
It is true.
Now, what part is true now? What part is true? Is the first part or the second part?
Equal to.
Equal to is true, right? So it doesn't matter if they are exactly equal or if one of them is less than the other one, right? It doesn't matter. So it means they are, that is exactly true. So when I come back here then, if I ask you now, is any number between 0 and 2 less than or equal to 2, absolute value of any number here? It is, right? Because whether you take 0.5 or you take 1, 1.5, 1.6, 1.7, all of them absolute value is less than 2. But just like you said, it's not the only ones. Look at the numbers to the left side. If you go all over here, all the numbers here between 0 and -2, what are their absolute value? Is it less than 2? Take -1. How much is absolute value of -1? Is it 1, right?
Yeah.
Is less than or equal to 2. Take -1.5. How much absolute value is 1.5 less than or equal to 2, right? So which means these numbers also work. But when we go beyond -2, is that true anymore?
No.
No. When you go beyond 2 to the right side, is that true anymore?
No.
No,
No.
right? So the solution to that is only here. So what you're saying here is absolute value of x less than or equal to 2. It means -2 is, x is between -2 and +2, right? Okay. For the absolute value of x to be less than or equal to 2, x has to be between -2 and +2, right? Okay, that is so. You see, you don't do no work until you break it down like that. Okay, so if I say absolute value of x is less than or equal to 7, how am I going to break it down? Let us say
-7.
-7
is less than or equal to x.
yes,
which is
less than or
greater
equal to what?
Yeah, 7.
Right, etc., etc. So, okay, now comes the equation now, the real equation now. When you say solve absolute value of x minus 3 less than or equal to 6, you don't do nothing inside the absolute value until you get rid of it, right? Okay. For instance, what is something we cannot do at this stage? What is something you cannot do? If you do it, your work is wrong from there.
Add 3.
Add 3. Thank you. If you decide to add 3 at this stage right here, you add 3. I stop grading your paper right there. I say this is wrong. Okay. So what you do first, you have to break it down into that way right here. You have to break it down. You have to remove the absolute value. How we break it down? Exactly what we did before. A very easy way to break it down is to do this, right? You see, I have the absolute value by itself. I'm on -6 here, +6 here, and then I put x minus 3 in between. You see? Everybody see that? Very easy way to remember. And this is what you have to do before you do any calculation. All right. And now you know what, now you know what to do to get x by itself. What you do now?
Add 3.
We add 3, we add 3. So we get negative
Negative
3.
3 is less than or equal to x, which is less than or equal to 9.
Thank you very much, right? So we get negative 3 less than or equal to x, less than or equal to 9. So this is the interval negative 3 all the way to 9, like this. Like this, right? It's negative 3, 9. Okay? So this is how we solve an absolute value inequality with less than or equal to, well, less than, right? So now, if I give you this one right here now, the two of them, right? And then okay, so these two, are you ready? Are we ready yet? Are we ready yet to break down the absolute value? What you have to do first?
No. You subtract 6.
Thank you very much. So you have to get the absolute value by itself and then break it down into a compound inequality, okay? So go ahead, do the first one, the second one. You see, don't go inside, do not even care first. At first, don't care about what is inside the absolute value. Try to get it by itself and then break it down into a compound inequality, exactly as we did before. All right, I'm gonna let you, like, you know, some good minutes for everybody to try. Please, everybody, I have to insist on, the participation, trying to do. When I say try to do that, I let you like 5, 7, 6 minutes to do that. I really want everybody to try to do that by themselves, right?
For the first one, the two solutions are negative 1 and 2.
You guys, the first one, you got a solution?
Yeah, negative 1 and 2.
Negative 1 and 2, okay. All right, yep.
I got the same thing.
Same thing, thank you very much.
Me too.
That looks, it looks right to me.
The two solutions are 13/5 and 7/5.
Okay. That's the interval, right? Okay.
Yeah. Oh, negative 7/5.
Negative 7/5?
Yeah.
No, it's the other one. It's negative 13/5.
No, I think it's 13/5 and negative 7/5.
Okay. Okay.
Is the first one -1 and 3?
When you
The first one -1 and 3?
-1 and 3.
Yes.
Okay, so you see when we write, okay, when you say -1 and 3, that is not an interval yet. So the interval would be -1, comma 3, and then you say whether you have a bracket or you have parentheses, right? You see, -1 and 3 is not exactly the interval.
No.
Yep. Yeah, I think it's going to involve, I think it could involve the numbers -1 and 3. I think so. All right, so right here, I think everybody did -6 on both sides. You had absolute value of 2x minus 1 is less than or equal to 3, right? Okay, now, like I said, don't do nothing to the inside the absolute value until you break it down into a compound inequality, right? Like this, -3 less than or equal to 2x minus 1 less than or equal to +3, right? And when you break it down into a compound inequality, you do not put the absolute value anymore. We don't have any more absolute value. So now we add 1, we add 1, we add 1, so we get -2 less than 2x less than +4, and then we divide by 2, so we get divide by 2, divide by 2, divide by 2, so we get -1 less than x less than 2. So we get -1, 2, right? So my interval is bracket -1, comma 2 bracket, right? That's my solution. This one we do about the same. So we're gonna add 10. We're gonna add 2 on both sides. I'm sorry, add 2, add 2. So we got absolute value of -5x plus 3 is less than or less than 10, right? Now we're gonna break it down like -10 less than -5x plus 3 less than +10, right? I know what you do next. You're gonna subtract 3. We get -13 less than -5x less than 7. And then when you divide by -5, you have to switch. -13 divided by -5 greater than x greater than 7 divided by -5, right? Okay, so which is 13/5 greater than x greater than -7/5. So we get exactly the same thing, -7/5, 13/5, and this is this one, open, right? -7/5, 13/5, just like that. Okay, so this is a case of the less than. The other case is a greater than. This case is maybe a little bit harder to remember, but let's try to do that. Now, if somebody tells you that, the second case says solve absolute value of x greater than or equal to 2 now. You see, what are the numbers whose absolute value is greater than 2? Again, let's do about the same here. Let's try to investigate those numbers. I have -infinity, +infinity, right? I have 2 somewhere here. Okay, I ask you a question. All these numbers to the right of 2, all of them here, do they verify this inequality up above?
Yes.
Yes.
They do, obviously. 3, 4, 5, 6, 7, 8, 9, 10. They all verify the inequality absolute value of x greater than 2, right? All of them. You see, this is one. I know this piece of solution is good. This is 2, infinity, right? This is x must be greater than 2, right? But are they the only ones?
No.
That verifies what other numbers verify the inequality
Negative.
also?
-2.
For instance, all the numbers like -3, -4, -5, -6, all those numbers also verifies inequality, right? If I agree with me,
Yes.
if I have -2 here, all these numbers right here, do they verify the inequality, all of them here?
Yes.
You
To the
see,
left of -2 or to the right?
yeah, I mean, all of them here, for instance, what is absolute value of -3?
Can I ask a question?
Oh, go ahead.
So we can say that the answer is all the linear except the period between -2 and 2.
Yes, that's gonna be the final answer. All the numbers except for this vacuum right here, right? So you see all the numbers on the red, on the green stuff, they also verify the inequality, because for instance, just as an example, absolute value of -3 is +3, which is greater than 2, right? Absolute value of -4 is +4, which is greater than 2, etc., etc., right? So which means these numbers also they work, which means -2 is greater than x. Okay, so we have -infinity to -2. Okay, so basically, look, basically, this inequality right here, and this is what you have to remember. This inequality breaks down as what? Breaks down as -2 greater than x, or x is greater than +2. Okay? This inequality breaks down like that, which means the outer intervals, right? The solution is the outer intervals. Okay? But you see, this is the only way to break it down, by the way. When I say that, some people might be, for the sake of, simplicity, some people might say, okay, let me break down this way, -2 greater than x greater than 2. Some people might say that, but tell me, give me one reason. You have like a bunch of them, but give me one reason why this way is wrong.
Because here we have or.
Exactly, because this way hides, remember what you said, this way hides n, right? And here, what you have in between? We have or, right? And besides, when you have something like that, when you remove the middle part, what do you read? If you forget the x, what do you read? -2 greater
Union.
than. When you remove the x, if you forget the x, you just skip from -2 to 2. What do you read? -2 is greater than 2, right? Is that right? Is -2 greater than 2? It is not. So this way of writing it is wrong. Please, don't break it down. This we have to separate, right? You have to separate, okay? So let us practice this way first. If you have absolute value of x greater than or equal to 9, how am I going to break it down? A very easy breakdown.
Yes.
-9 greater than x, or what? S greater than +9.
X.
Okay? These are the two ways to break it down, right? When I say absolute value of x greater than or equal to 7, how am I going to break it down?
-7 is
X is greater than well, -7 is greater than x, greater than or equal to x, and then
Yes.
X is
Or?
greater than or equal to 7.
Exactly. You see, and don't forget the or. When I say absolute value of x is greater than 13, I break it down as what? -13 greater than x, or x is greater than 13. You see, it's almost like the first case, except here we have to separate. here we have to separate. We have no choice but to separate, right? Okay. All right. So once we get that, now we go to the equation now. Now we go to the equation, for instance, the first equation, for instance, if I say solve absolute value of x minus 3 plus 9 is greater than or equal to, 13, right? What am I going to do first?
Subtract 9.
Subtract 9 on both sides, right? So we get absolute value of x minus 3 is greater than or equal to 4, right? Okay, now I'm going to remember this right here. You see? I'm going to say is -4 greater than or equal to x minus 3 or x minus 3 greater than or equal to +4. Everybody see that? How we break it down? 1 month from now, you have to remember that. 2 months from now, you have to remember that, okay? And now you do your last, you do what? +3, +3, +3 here, +3. So you get -1 is greater than or equal to x, or x is greater than or equal to 7. So basically, this is going to be always about the outer intervals, always. When it is greater than, your solution will be the outer intervals, always. When it is less than, your solution will be the inner interval, the one in between. When it is outer, when it is less than, greater than, your solution will be the 2 outer intervals, always. This is -infinity to -1, union 7 to infinity, okay? Again, so what is the main step here? What is the step we're going to try to remember? Is this one right here. That is step you have to remember, how to break it down. After you get the absolute value by itself, how to break it down into a couple of inequalities, right? That is the one you have to remember. All right, so try to do this one, this 2 right here. So if I say absolute value of 2x minus 7 plus 3 is greater than or equal to, 8. Okay, so try to do, yes, go ahead. Yeah, yep. Yeah, you see, when you see minus -17, so the only stuff risky about this way to write is, now we have to put parentheses around -1 and 7. Because if you don't put parentheses around -1 and 7, now you are including -1 and 7. You are including with the numbers that we have to restrict. Okay, that is, of course, I'm glad to see that, because this way of writing is, in 163, we don't use that a lot, but if you know math a little bit, if you know math, you are used to math, you see those ways of writing solutions, okay?
So it will be like this.
Yeah, exactly. Yep.
Thank you.
Yeah, I'm glad to see that. Okay.
Thank you so much.
All right, so everybody try to do this one. Everybody, please.
Are we allowed to give answers now?
All right. So let's like a couple of minutes for everybody to finish. And then you're gonna give me the steps. All right, so Elijah, so can you give me the steps, please? What you did first?
You subtract 3 on both sides, and then you get 5.
Mhm.
Then you carry everything down, and you get -5 is greater than or equal to 2x plus 7. I mean minus 7.
Yep.
Then you get which is greater than or equal to 5.
Okay, so, but I don't put them like at the same line. You see, I cannot do that. Okay.
Right.
This is what I said.
That's what I meant.
We don't do that. We have to split, right? Everybody, don't write it this way on your test, because mathematically we cannot compromise with this mathematically, right? So we have to exactly earlier. So exactly. So this is exact. So we have to separate. We have to 2x minus 7 greater than 5, right? Thank you. And then now we solve, right? What you did next?
You add 7 to each side.
You add 7 to each side, right? So, and then you get 2. The first one, you get 2 greater than or equal to 2x, or 2x is greater than or equal to 12, right? And then lastly, you divide it by 2. You get 1 is greater than x, or x is greater than 6, right? So this will be the outer intervals, right? It's going to be the outer intervals, which is 1 here, 6 here. It's going to be this interval and this one, right? So it's going to be negative infinity, 1 bracket union, 6 bracket infinity, right? All right, so these are the two these are the two solutions, right? And it's going to be always the outer intervals. All right, so just to let you know, the quiz will be about only, I think, about, quadratic equations, one absolute value equation, not inequality. What we did today is not on the quiz, okay? And complex numbers, I mean, you're gonna laugh, it's gonna like some easy quiz, okay? But please try to adhere to the time, right? You have like a day and a half to do like 4 questions or 5. You know, please don't come like Thursday and tell me I didn't do it because, you know, normally if it was face-to-face class, we would do the quiz right here, you know, in classroom, okay? So everybody has the time to do them. There is no way somebody can miss the quiz like for 1 day and a half, right? So it's gonna be available at 2:30. So, you know, and try to do it and then, you know, try to do it like seriously, okay?
How long is it open for?
Yeah, it's gonna be open until Thursday noon, but don't wait until then. Try to do it today. But you know, once you hit start your quiz, when you hit the start button, you will have 35 minutes to submit on Brightspace, right? This is like a quick quiz. I think it's going to take you like no more than 15 minutes to do it, okay? Frankly, or maybe 20 to the most. So, you know, once you hit start, you'll have like 35 minutes or, you know, maximum 40 to submit, right? When I say 40, I'm putting in it, you know, the time to scan your paper, stuff like that, okay?
Can we use our notes, or do you want us not to?
Use what?
Notes.
I mean, okay.
That
is a very good question. That is a very good question. You see, about academic integrity, like I said, if it was a face-to-face class, it wouldn't be no notes at all, okay? So now, I think, you know, I guess it's something I cannot control. It is a take-home quiz. So I think some people are going to use notes, but on the test, there will be no notes. The test will be on Zoom. I will be watching, okay? So nobody's going to use no notes. And if you want to play the integrity card all the way, so you can do it without notes. So this way, you know, this is really, really, really what you are capable of, okay? But unfortunately, I have no way to enforce that, okay? But for the test has no notes, okay? The test has no notes at all. All right. Thank you, everybody. I'll see you Thursday.
See you Thursday.
Thank you.
Thank you.
Have a good day.
Have a nice day, everybody.
Thank you.
Bye,
Bye.
Have a great rest of your week. I'll see you Thursday.
Thank you. Thank you very much.